All right, so in this next part, what I really just want to emphasize is how great Pythagorean theorem is and how we can use it in a lot of instances. So in the figure shown, we have L, which is the center of a circle. All right, so this is kind of a circle problem. And we got PQ. Well, what the heck? PQ is a chord. We haven't learned about that yet. All right, well, this chord, PQ, whatever that means, is 30. Cool. What is the length in centimeters of PL? All right, well, fun fact, PL would be a radius. But nonetheless, all right, we got a circle, haven't learned that yet. We got a chord, what is that? I don't even know what that is. But look at this. All right, why I wanted to do this problem right now, a circles problem in Pythagorean theorem, is because look, we have a right angle here. That means we have a right angle here. We have a right triangle. All right, furthermore, this length is 15. All right, so when in doubt, we have these right triangles where you can just utilize Pythagorean theorem a lot, and we'll just call this side C. All right, so if you can identify we have a right triangle, then it's going to make life a lot easier moving forward. All right, right triangles come up a lot more than you might be aware of. All right, just doing the classic computations, it's 17. That's the answer. All right, so with a circles problem, talking about chords and all this stuff, just boil it down, find a right triangle, bada bing, bada boom, 17. All right, next one right here, we're going to be practicing finding exact values. All right, exact, that means it can't be a rounded decimal. All right, so well, all I know is that 10 is C because it's opposite the right angle, so x is like my a and b. So I'm just going to do x squared plus x squared equals 10 squared. And remember, we talked about in this video yesterday, is this 2x squared or x to the power of 4? It's that one, it's 2x squared, all right? Remember, it's just combining like terms like how this is a 1x and a 1x. All right, since it's a 1x squared and a 1x squared, it comes 2x squared. You don't add the exponents together. I'm going to erase that. Actually, I won't erase that. I'm just going to cross it out. So we get 2x squared equals 100. All right, and then continuing to move forward, do I divide by 2 or do the square root? Well, it's a reverse order of operations, sad mep. So divide becomes before exponents, so that's why I'm going to divide by 2. So we're going to have x squared equals 50. Sweet, I'm starting to get close to my final answer. Do the square root of both sides. I'm going to get x equals the square root of 50. Now, perfect square factors. What are my perfect square factors? Well, 1 never helps. 4, 9, 16, 25, 36, 49. My largest perfect square factor, in this case right here, hopefully you can tell, is 25. All right, so remember, we need to find the perfect square factor. The perfect square factor goes first. Square root of 25, it goes first, and it's under the square root. And then the other factor, 2. All right, and then what's the square root of 25? It's 5. What's the square root of 2? Can't be reduced, it's the square root of 2. So that's the exact answer for x, 5 radical 2. All right, in this problem right here, what is the exact area of the rectangle? Again, here's just another crazy way where, boom, we have a right triangle. All right, because what's the definition of a rectangle is a quadrilateral with 4 right angles. So when we split in half with a diagonal, boom, a right triangle is formed. All right, so A, B, C, A squared plus B squared equals C squared. 7 squared plus B squared equals 8 squared. All right, so then we're going to have 49 plus B squared equals 64. Subtract 49 from both sides. I'm going to get B squared equals 15. All right. Take the square root of both sides, and B equals the square root of 15. That's it. Pretty cool. All right. Well, that's it for that. And now it's asking for the area of a rectangle. So remember, the area of a rectangle is just base times height. All right. So we're going to say the base is 7, and then the height was radical 15. So the exact area is just 7 radical 15. That's it. Pretty cool. All right. Now we're going to have one more page of problems and then call it